Welcome everyone. My name is Duane Friend. I'm an extension educator with U of I Extension, and looks like we've got about 56 participants on the program today, so that's great. Glad to have you all on here. We are one of the things I do want to mention right up front is I am going to have time at the end for people to ask questions. So if you don't have a chance to ask them during the presentation, just write them down, and we'll take them at the end of the program. You can just put them into the chat box, and we'll take them as they come. So going into this program, I want to give you a little bit of background about myself. I've been with U of I Extension since the mid-90s. My academic background is basically in earth science, physical geography, that area. Got a lot of my soils training actually after I got out of college. My first job was with a soil and water conservation district. There I got to learn how to develop conservation farm plans, learn how to make soil erosion estimates. Also got to learn how to do some conservation erosion control work. Somebody said that my mic is fading. I've got it right in front of my face with my headset, so I'm not sure what's happening there. If it still happens, let me know. But as far as my work with the Soil and Water District, I did that for a few years. And then also during that time, I got to do a little bit of part-time work working for a soil survey, where I went out and mapped soils as part of a soil survey that was being done at the time. After that, managed an office for what's now called the Farm Services Agency, did that for a few years, and then got on with U of I Extension in the mid-90s. And most of the educational programming that I do is in the area of soil quality, some on water quality, and then I also do some programming in weather and climate. So that gives you a little bit of background about myself. You can see the picture on there. In the past, when there wasn't a picture, I would tell everyone just to imagine a young Alec Baldwin. Now, obviously, that's nowhere close to what I look like, but at least in that case, when you would hear the name, that's what you would think of. So in any case, let's go ahead and get started for today. So what we're going to do is go through and talk about soil quality, soil health, kind of give you some general definitions of what that means, but also give you a little bit of history of our soils in the Midwest, why we have such great soils for growing things here in the Midwest, and not just Illinois, but throughout the Midwest. The other thing that I want to focus on is the ecosystem that is taking place within most of our soils, the microbiology, the critters that really help our soils function as they do. We're also going to talk a little bit about how we change those soils over time, and how when a soil becomes disturbed, it typically loses some of that inherent productivity that it normally has. And I'll say right off the bat, I don't want it to make it sound like we have totally destroyed our soils. We have not. But are they the same soils that they were 200 years ago? No, that's not the case either. Okay, somebody says they can't hear in Logan County, and I'm not sure how to take care of that. If anybody else knows how, that would be great. One of the other things that we can do, or that we're going to do, is to talk about, since we have disturbed those soils, and since our soil quality has been lessened in some cases, what we can do to maybe bring that quality back better to where it was. So we'll talk about some options on how to do that by adding organic matter into that. So moving into this, one of the first terms we need to talk about is soil till. And you may have heard of that term a lot of times before. And it's not really an exact type of terminology. It just means that if that soil is easily workable, if it does well for planting, and if it allows that plant to grow well and doesn't impede it in any way, then that is considered to have a good tilt to that soil. Again, it's really dependent on the soil type and what the person is trying to do with that soil. Now here in the Midwest, and you'll hear lots of people talk about our soils here in the Midwest, most people, especially farmers, will say we have some of the best soils in the world for growing things. And we do. And there's several reasons why our soils are so incredibly productive. One of the reasons is that in geologic time, our soils are young. Now, in geologic time, what does that mean? Our soils are only about 10,000 years old. If you look at other soils around the world, we're talking hundreds of thousands or millions of years for those soils to have been around. And the reason our soils are so young is because up until that point, we've had multiple ice ages come through the Midwest and basically scour the landscape, deposit material, and then new soils have formed out of that. So every time we've had an ice age, we've had new deposition, which then will form the parent material for new soils to form out of that material. Our last ice age ended about 10,000 years ago, so that's why our soils are relatively young, especially in the northern and southern part of Illinois. I'm sorry, the northern and central part of Illinois. Southern Illinois, those soils are probably at least 100, if not 200,000 years old, because the last ice sheet didn't cover the entire state. So those soils are a little bit younger, or a little bit older. But in any case, our soils in geologic terms are young soils, and typically the younger the soil is, the more productive it's going to be. Another reason that our soils are so good is that we have a cold season. We have winter. During that cold part of the year, microbes in the soil shut down. And it's the microbes that break down organic matter. And typically what you see is the colder the climate, the higher the amount of organic matter that's going to be present in those soils. If you look at tropical soils, for example, even in rainforests, where you may think there would be a lot of organic matter in the soil, there's almost none. Because in those warm tropical climates where it's warm all year long, the microbes in the soil quickly break down any type of organic matter that may come into contact with the soil and allows those nutrients that may be in that organic matter to go right back up into living material. So tropical soils typically have very little organic matter in them, which in that case also makes them not very productive. Now they're great for rainforests, but then if you try to clear those areas and do something else with them, those soils are not very good for trying to grow something else. Another reason why our soils are so good, again, especially here in Illinois and in the Midwest, is that prior to farming these soils, if you look at especially springtime and even into midsummer, these soils stayed wet throughout most of that period. If you looked at central and northern Illinois in particular 200 years ago, you would have seen that most of those soils were soggy, probably up until about midsummer. And in fact, there's one story about back in the early 1800s when there was some surveying being done in Champaign County, where the surveyor said that he could probably canoe from one end of the county to the other. Now what that does is when those soils are saturated with water, the microbes are not able to function because they need oxygen to be able to do their thing. When all of those pore spaces in the soil are filled up with water, there's no oxygen, the microbes are not able to decompose organic matter. So that shuts down the time period when organic matter decomposition can take place. The other thing that has added huge amounts of organic matter into our soils here in the Midwest is what grew on those soils for hundreds and hundreds and hundreds of years. And the majority of that area was under prairie. Now I've got a couple of slides here that I want to show, and this first one shows what would be typical for a prairie soil. Now we can group all these different types of prairie soils together, into what's called a soil order called mollisols. So a mollisol is just a grouping of individual soil types, but they all grew under prairie vegetation. Prairie soils, very high in organic matter, very high in mineral or nutrient content, so they've got a lot of inherent fertility to them. They're also, those topsoil layers are very deep in most cases, at least if erosion hasn't taken away a lot of it, and they're extremely productive soils. Now, one of the things you'll notice in this slide is the very dark color, especially at the top. The darker the color of the soil, the more organic matter in that soil. And typically prairie soils, back before we started tilling them, had organic matter contents anywhere from probably 3 to up to 6% organic matter, which is just an incredible amount of organic matter. If you talk to other people around the world, look at other soils around the world, they're very envious of that organic matter content that we have here in the Midwest. Now, another type of soil that's also very common here in Illinois, especially in southern Illinois, are soils that formed under timber or under forest. And those are grouped into the soil order known as alphasols. Now, you can notice there is some difference between these. First of all, look up at the top. Now, you still have a fairly dark layer there, but notice how much thinner it is. The total amount of organic matter in alphasols is typically substantially less than what mollisols have. While mollisols originally had 3 to 6% organic matter, alphasols typically only have about 1 to 2% organic matter. So much more organic matter contents in those soils. And again, it's organic matter that really drives the productivity, one of the main things that drives soil productivity. So again, what grows on that soil really affects what that soil becomes. And if you looked at most of Illinois, what grew on those soils? Prairie. And when you're looking at this slide, everything that's in yellow was where there was original prairie in the state. A little over 20 million acres of prairie in Illinois. Anybody have an idea of how much prairie is left in the state? Native undisturbed prairie. It's about 1/100th of 1% that's left. Now, people are restoring prairie, but that original undisturbed prairie is essentially gone. And some of you may grow prairie. Probably a lot of you have seen prairie, at least. So you're very familiar in a lot of cases with what prairie looks like, at least above ground. It's very tall, so you have a lot of material up there. But that's not what created all the organic matter in our soils. It's what grew underneath. Now, if you're looking at this slide, and you may not be able to read the numbers over on the left-hand side, but each one of those little markings represents a foot of depth. And I've got the 5-foot depth and the 10-foot depth indicated there. And then a few of the plants that are in there, the Indian grass, the big blue stem, and the blazing star. Look, for example, at the blazing star. Not a big plant in terms of height, but the root system can extend down to 15 feet below the soil surface. All of these prairie plants had very massive, very fibrous root systems. They oozed organic material into the soil. This is what added the organic matter into our prairie soils, is the root systems from those prairie plants. Now you might think, well, we had that above ground growth. Didn't that add organic matter to that soil? Not really, because what happened to that above ground growth periodically? It burned. And if you've ever seen a prairie burn, it's awesome and scary at the same time. Now, these flames can leap up 30, 40 feet in the air. But this is what happened periodically in the prairie. And that's also what made that prairie stay in place. We had enough moisture in the area to support trees. Prairies are more of a dry land plant. So why did we have those there? Because these fires came through periodically, kept the brush and the trees from taking over that area. And if you talk to a lot of anthropologists or other folks, archaeologists, a lot of those folks will say that this was a managed landscape, that the prairie was managed to be a prairie to promote those prairie plants, which would help bring in bison and those types of animals for sustenance. Now I want to go back just a second here on this slide. If you notice off to the left-hand side, I've got a red circle and a question. Anybody have an idea of what that is? Well, that's what we grow on our lawns today. That's our bluegrass. How deep does that root system go down? About 3 or 4 inches. Is that going to add a lot of organic matter into our soil? No, it is not. Now, the next thing I want to talk a little bit about is that microbial system within the plants. Now, depending on the type of root system that is present, again, the environmental conditions, there's a wide range of microbial populations and species of microorganisms. That changes throughout the year. Where most of the action takes place is in the root system, and in fact, right next to the root itself. Right where the roots are at, there's 1,000 to 2,000 times more microbes with the root system as opposed to what you would find in fallow or tilled soil. One of the most important microbes that you're going to find, especially in a prairie soil, and this is true not only for the prairie, but for trees, for garden plants, for crops, is a type of soil fungi. This soil fungi works in conjunction with the roots themselves. And this is especially true with the prairies. They used this fungi, even though they were a big root system themselves, they used this fungi as an extension of that root system to be able to bring in additional water and nutrients. And this type of fungi has a name called Arbuscular Mycorrhizal. There's a couple of different ways that this type of fungus works. In some cases, it just more or less works on the outside of the root. It doesn't penetrate into the root itself, but it still brings in nutrients and water to that root. Now that fungi gets some benefit from that root. It gets some things that it needs to continue to function, but it's a symbiotic relationship. It's necessary for that plant to do well to have that arbuscular mycorrhiza present. Again, what they do is they help bring in nutrients to that root system. They reach out much, much farther than what the roots themselves do. These mycorrhiza can extend yards and yards away from where the root system is itself. And we've been talking about prairie plants. These also work extensively in tree systems or in timber or forest areas. One of the other things that's extremely important in this symbiotic relationship is some of the material that is given off by this arbuscular mycorrhiza fungi. And this is something that wasn't discovered until about the mid-1990s. But there's a substance that's exuded by this mycorrhizae that's called glomalin. And it's been discovered that this glomalin acts as a superglue to help produce structure within a soil. So when you look at a good soil and you look at that topsoil, that A horizon, what do you like to see in terms of the structure of that plant? Do you want to just grab a blob of a handful of material, or do you like to see little crumbs? Well, those crumbs are actually a type of structure. They are millions and millions of individual soil particles that have combined together to form that crumb structure. And it's been discovered that this glomalin is one of the main ingredients that allows those individual soil particles to glom together, I guess that's where they got the name, together into forming that crumb structure that we like to see in a good topsoil. Now, talking about structure, again, in that A horizon, in that topsoil, two very common types of structure that we're going to find is granular structure and crumb structure. They look very similar. Again, they're very small pieces, but they're not just singular soil pieces. Again, they're hundreds of thousands to millions of individual soil particles, sand, silt, and clay particles that are combined together to form that crumb or granular structure. Now, when you get into lower parts of the soil profile, you get into the subsoil or the B horizon, you may find some different types of structure present. Typically here in Illinois, one of the more common types of structure that you're going to find in the subsoil or the B horizon is either going to be a blocky structure or columnar structure. Blocky structure going to be a little bit larger than the crumb structure, but again, kind of looks like little blocks. The columnar structure may be a little bit harder to see when you're looking at a soil profile. For example, if you dig a trench and you're trying to find the structure in there, it may be a little bit hard to see that columnar structure, but it's essentially just pieces of soil that are combined together, and they're a little bit taller than they are wider. So that's, I guess, a way to describe columnar structure. Prismatic structure, we don't find quite as much here in Illinois. You might find it more out in western type soils. And then in the area that I grew up in, which is in southern Mason County, which is sand, that sand doesn't aggregate. It doesn't combine with other soil particles, so it's single grain. And when you dig down deep enough, when you get down about 3 or 4 or 5 feet into the ground, you're down below the zone where those soils have actually formed. Again, those soils have formed out of a parent material, whether it's something from glacial deposition or wind-blown material or something like that. That soil formed out of that material. But when you get down to about the 4 to 5 foot level, you're down below the zone where those soils have formed. So you're in that original parent material. And down at that depth, that structure has not formed. And so there essentially is no structure. It's called massive structure. But you're in that original parent material that hasn't undergone any type of change. Again, this Micah Riser is really important, especially this type called endomycorrhiza, which you'll find in fields and gardens. And what they do is they form a membrane around the root system itself. It protects that root system, but it also helps, again, bring in water and nutrients to that plant. They're working together. They help each other out. Here's an example of what can happen in an area if you leave a soil bare or continually till it. So as you're looking at that picture of the corn there, if you notice there are sections where no tassels are present. Those are sections where those areas were kept tilled. That mycorrhiza was not allowed to form to any great extent, or it was torn up. The areas that you see where the tassels have taken place, you had much less tillage done, you had time for that mycorrhiza to develop. Now, another part of this, in terms of things like soil bacteria, other types of fungi, but in most cases, it's especially the bacteria that do a lot of this work within the soil, is that when a piece of organic material gets into the soil, there's a lot of tied up nutrients in there. What these microorganisms do in the soil is they break that material down. They break the organic matter content down, breaks the complex bonds that a lot of those nutrients are tied up in, and then allows those nutrients to be taken back up by the plants. When the release of those nutrients are taking place, that's called mineralization. When living plants take those nutrients back up into the living systems, they're no longer available for other plants, and so they're immobilized. And it's just one part of many of nature's cycles that takes place, where you have mineralization or release of nutrients, plants take those nutrients back up and immobilize them, and it just goes through a constant cycle. But it's the microbes in the soil that make that happen. When we disturb our soils, though, we do a number of different things to it. For example, if somebody is doing a new development, what's the first thing that's done with that topsoil? Do they keep it in place? No, they usually shove all of it off to the side. You may have had an originally 18-inch topsoil layer in there, or a horizon. Are you going to get all of that back? Probably not. You may get back a few inches of that topsoil, enough to get grass growing, but you probably have lost a lot of that original topsoil and won't get it back. When construction is taking place, you've got a lot of heavy equipment in there. They've got deadlines to meet. They're going to work, rain or shine in some cases. Those heavy equipment move across the soils, they compact the soil, which then also is going to constrict air movement within that soil, because if you scrunch those pore spaces up, you no longer have as much space for air to be present. You may end up having a soil that crusts over because it's lost a lot of that structure that was originally present. Depending on what's being done in a particular area, the pH may get changed. You may end up having an elevated pH in that soil. And all of these things can lead to a lack of nutrient cycling. This is one slide that I like showing. This just shows what happens when you excessively till a soil in terms of soil structure. Now, in these two glass containers, originally these pieces of soil were the same size. This was after about 15 minutes of being present in water. So both of these containers were filled up with water. They then placed these clods of dirt, I can't think of a better word at the moment, but these pieces of soil into the water and just let them sit. And after 15 minutes, you can see how that tilled soil is breaking apart. It's essentially exposing those bonds that are in there, that the structure there is very weak. And so what you end up with is all of those individual soil particles fall down to the bottom. On the other hand, in this case, where a soil is not tilled, those structural bonds, that soil structure is much stronger. And it keeps that structure in place, doesn't allow it to be destroyed. So take, for example, if you have a heavy rain, what do you think is going to happen to each of those soils in terms of soil erosion? The other thing to know about soils is it takes a very long time for soils to form. For 1 inch of soil, it's going to take hundreds of years for just 1 inch. Now, I want to preface that by saying that even though it takes that long, all soils can afford to lose a small amount of material and still remain productive. Erosion by itself is a natural process. The problem comes into play when we have excessive erosion. Now, for example, on our best soils here in the Midwest, the Natural Resources Conservation Service says that those soils can afford to lose up to 5 tons of soil per acre per year and still maintain their productivity. Now, that sounds like a lot, doesn't it? 5 tons? Well, if you spread 5 tons of soil out over an acre, what thickness do you think that is? you take your thumb and forefinger and put it as close as you can together without touching. That would give you about 5 tons per acre per year. So it's not very much. Our poorer soils can only afford to lose maybe about 1 ton per acre per year. So that would be considered natural erosion. But when we look at disturbed soils, and I go back to when I was doing conservation farm plans as a resource conservationist, and I would have to estimate the amount of erosion taking place. Now, this was back in the mid to late 80s. There was still a lot of moldboard plowing being done, so that soil was physically being turned over, so you had a lot of bare soil in place. But there were a lot of fields on what would appear to be very slight slopes that were losing up to 15 to 20 tons per acre per year of soil. So they were losing 3 to 5 tons, the tolerable rate of erosion. Definitely not being able to keep up with that natural production of topsoil that was taking place. They were losing much more than they were gaining. No matter what type of soil you have, it's disturbed, it has some degradation. Now again, I'm not saying that we're destroying our soils completely. All I'm saying is just be aware that when we disturb our soils, it's no longer in its natural state, and so there's some degradation that takes place. It can lead to such things as excessive erosion, like I just mentioned. It can lead to compaction of the soil. It can lead to changes in pH. And I know we probably have several folks that are master gardeners on the program today, and other folks that garden, and you know that most garden plants like a certain pH range. If you get out of that pH range, plants may not be able to take up the nutrients that they need to function. And one of the other big things that can happen is when you disturb a soil, you're destroying some of that structure. And so you have a decrease in that structure, a decrease in aggregation. And it doesn't matter whether you're talking about an agricultural setting or a garden setting. If you're losing organic matter, which is going to be happening if you have topsoil being lost, or if you have compaction, both of those can happen in a garden or agricultural setting. We may be looking a little bit different in terms of scale, but both of these can take place in both areas. Again, when you look at a development, you've got a lot of things going on there. You may go in and buy a new house in a new area, and that lawn may look okay, but you don't know what that area looked like before that lawn was put down. Again, you can have compaction, you can have maybe only a few inches of topsoil to work with after it's been reconditioned. You may have changes in pH. There's a number of things that can be taking place, and you may not have been aware of what was going on before you moved into an area. The other thing to realize, and I throw this slide in here, when we lose organic matter, where is that material going to? Well, it's basically going up into the atmosphere in the form of carbon dioxide. When soils are warm, we have a lot more organic matter decomposition taking place, and therefore we have more decomposition occurring. This is showing different situations where we have different tillage systems, and it's just basically trying to show that after tillage, if those soils are warm, what you've done is you've added oxygen into that system as well, which allows the microbes to just go crazy. You have very rapid organic matter loss when tillage is done and when the soils are warm. Now we know in some cases we have to till, and we have to get that seed bed prepared. And I don't want to make it sound like if you want to till that you should. We know in some cases that you have to. What I always tell folks is don't till any more than you absolutely have to get the seed bed that you need. don't do recreational tillage. If you've got a new rototiller out there and you're really wanting to use it, please don't go out there and till that soil 4, 5, 6 times, because you're destroying the structure, you're adding to compaction, and if you especially do that in wet soil, you're really doing a number on that soil. You're going to have so many more problems than you would if you waited until it was dry. So please don't do tillage in wet soil. So we talked about a number of situations where our soils have been degraded. So what can we do to improve those soils, kind of bring them back to a natural condition? Well, a couple of different ways that we can do that, which we're going to focus on now. We can add other types of organic matter into that soil. We can add compost into that soil, a high quality finished compost. Or one of the other things that I'm going to talk about that really has come into play more recently, not only on the ag side, but I'm going to show some slides where there's been some research on the garden side, is using cover crops to add organic matter back in. So adding organic matter in the form of residues. Again, organic matter is extremely important in soils. It helps with water retention. It helps with nutrient holding capability. It helps with soil structure. So the more organic matter you have in the soil, the better. And I should add to that, though, a finished type of organic matter. In other words, a fully decomposed type of organic matter. And I'll explain more about that here in just a few minutes. What are some things that you can add into the soil that would add organic matter? Well, a lot of it depends on what you've got available. Any type of organic matter is typically going to work fairly well. Peat moss, corn cobs, leaves, grass, compost, all of those are good types of organic matter. To give you a little bit of an idea of how much to apply, if you're going to use peat moss, one of the first things you want to do is you want to make sure that that moss is wetted down, because it does have a tendency to suck water out of the soil if you apply it when it's dry. A rule of thumb for peat moss applying it is about 5 pounds per 100 square feet, and working that into the top 6 to 8 inches of the soil. For corn cobs, about 2 bushels per 100 square feet. For leaves, since they're a little bit less dense, about 3 to 4 bushels per 100 square feet. Manure, about 5 pounds per 100 square feet. Compost, about 3 inches worked over the top of the soil. Now with grass clippings, again, grass clippings will work. It's an organic material, but we just put a little bit of caution in there to err on the side of safety. If those grass clippings have been sprayed with herbicides, now herbicides typically, especially this time of year when it's warm, they degrade very quickly. But if you're going to be using it directly into a soil as a soil amendment, we just say to err on the side of safety, and don't use those grass clippings that have had something sprayed on them. Now, in a lot of cases, when you've got these materials that you're adding, you may also have to add some supplemental nitrogen with it. For example, if you add corn cobs, you want to add about 1 pound to 1.5 pounds of nitrogen for every 4 bushels of corn cobs that you apply. For leaves, also about 1 pound of nitrogen for every 4 bushels. Now I'm going to stop here for a second. I see we've got a question here. It says, when adding peat moss to the top 6 to 8 inches, how do you efficiently work it into the soil if protecting no-till method? Well, this is a situation where there's going to have to be some necessary tillage. If you're trying to add organic matter quickly into the soil, you're going to have to work it in. If you're wanting to build up your soil without tilling, that's going to take a little bit longer, but it's kind of a different situation. So, it may be something where you add that organic matter and then start your no-till after that. So it's something that you're going to have to consider on which option you want to go with. Now compost, and I'm sure that there are some folks out there who have also heard me talk about compost. Compost is one of my favorite soil amendments because it's already gone through the decomposition process. You don't have to worry about adding nitrogen to a good finished compost because it's already fully decomposed, or at least gotten to a point where it's very stable. It's not going to pull nitrogen out of the system. And let me back up for just a second here. The reason you have to add nitrogen to some of these soil amendments is because of something called the carbon-nitrogen ratio. Organic material has carbon in it, has nitrogen in it. But some materials have a lot of carbon, excuse me, and almost no nitrogen. Those types of materials, if you add them into a soil as a soil amendment, and you try to plant immediately after that, your plants are going to look very sickly. You're going to exhibit nitrogen deficiency symptoms because while that fresh organic material is being decomposed in the soil by those soil microorganisms, if they can't get the nitrogen from that organic material directly, they're going to pull what they can get out of the soil. And so it makes it temporarily unavailable for plants to use. So that's why those plants, if you plant directly into something like that, is going to exhibit a nitrogen deficiency. And that's why we tell you to add the supplemental nitrogen under those situations. So essentially, any type of brown organic material has a lot of carbon, very little nitrogen. You're going to probably have to add some supplemental nitrogen into that soil if you're going to be planting into it within, say, 3 to 4 to 6 weeks after you add that organic material into the soil. So in a lot of cases, it may be better to work this stuff in the fall, give it an opportunity to decompose, and then try planting into it in the spring. Now for the compost application, again, you want to apply about a 1 to 3 inch layer. Again, it's going to need incorporation about 4 to 6 inches deep. You can either do that by shovel or using that rototiller. So again, this is going to take some tillage to do this. Whenever you're adding this type of organic material directly into the soil, it is going to necessitate some type of tillage operation. If you're wanting to put compost on grass, again, you want to use a very high quality compost. There are very many things out there that are called compost, and it's not really a good finished product. You need to be kind of wary of that in some cases. It may still have high ammonia content to it, still may not be a fully finished product. So you've got to try to make sure that you get a good high quality compost and just very lightly put that across the top of the turf. Now in this case, you're not going to do tillage, but it's going to benefit if you can do an aeration operation right afterwards. And this will help, especially if you've got a thatch problem. It'll help degrade some of that thatch, but it will also very slowly help improve the physical structure of the soil. So in this case, it's going to be a very slow process. You're not going to see huge results after that first year of putting topsoil, or compost on. Now, the other thing I want to talk about, and again, this is something that really hasn't been talked about to a great extent, is using cover crops. And what we're wanting to do here is, instead of leaving that soil bare for part of the growing season, we want to have some type of living root system in place for as much of that growing season as we possibly can. Because the longer we have that living root system there, the more we've got that mycorrhizal fungal activity, the more we've got that bacterial activity taking place. And so when you go to plant into that the following year, you've got that microbial system already functioning, and you've already added some additional organic matter into that soil from the root systems from those cover crops. Remember when we talked about the prairie plants and how the root system was doing the work of adding organic matter into those soils. Couple of the other benefits from this: if you've got a cover on that soil, the amount of erosion that's going to take place on it is going to be lessened, especially if you've got any type of slope on that soil. The more cover you have, the less erosion that's going to take place. It also helps reduce leaching of minerals. It helps with compaction. Now, typically in most garden and horticultural settings, when we talk about compaction, that compaction is not very deep. In a lot of cases, these cover crops can help reduce or alleviate the amount of compaction that's taking place. It's also been shown in some cases that it can suppress perennial and winter annual weeds. I'll show a slide of that here in just a few more minutes. And the other big benefit is it provides organic matter and opens up aeration and water movement passageways into that soil. What are some potential cover crops? Some of you may have heard of tillage radishes. This is being used pretty widely in an agricultural setting, but you can also use it in a garden setting. Ryegrass or cereal rye is something else that can be used. Legumes, such as hairy vetch, can be used. Now, some of you that may not be familiar with the tillage radishes, these aren't the type of radishes that you plant in the spring and that you use in your salad. These are, again, very large plants, or at least they can become very large plants. And one of the reasons that this has gotten so much attention as a cover crop is that if they are planted about, starting in about 2 to 3 weeks, by the time you get to October, these things are huge. These are big compaction busters. They add huge amounts of organic matter into that soil, and you'd just be amazed at how quickly they grow. This is an example of what a tillage radish looks like. This is something that has probably been growing for maybe a couple of months. And this is how big a tillage radish can get. So you can see they can get very sizable. Those tubers can go down well over a foot in depth. Now the thing with these is once you get the first hard freeze, they die out. So this is something that doesn't overwinter. It dies out when that first or second hard freeze comes in. There's been some research on these, and it shows that if you plant those radishes in place, they help eliminate almost all weed growth while they are growing. And in some cases, they've been shown to also help suppress spring weeds as well. Now to do this, you've got to plant them at least 6 weeks before frost. So typically, we're talking anywhere from about mid-August through mid-September, depending on where you're at. And you want to try to get at least 5 plants per square foot to make that happen. Here's an example where you see that bare area. That was where the tillage radishes had been present. And you can see how they've almost completely eliminated any type of winter, annuals, or early spring weeds in this case. Now, am I going to tell you that that works 100% of the time? No, but it does have the potential to do that. Here's what the holes look like after winter kill. Again, those holes will fill in with soil, so it's not something where you have to worry about those holes being present all year long. But again, it shows what good of a job it does in terms of aeration, and those, you don't have to pull the plants out or anything like that. They're going to be gone come springtime. Cereal rye is something else that works well. Now with these, you have a little bit more of a planting window with this. With the tillage radishes, typically by mid-September, that's about the last planting date that you could go with. With cereal rye, you can go into late October. And it will still come up. It may not get very tall, but it will overwinter and come on then in the spring. And it comes on very quickly in the spring. It's asking if everyone else has audio. Hopefully they do, otherwise I've been talking to myself. Okay. And here's an example of that. Again, this overwinters. It's going to suppress weeds, but you have to keep an eye on it. You don't want to let it, it can overtake an area very quickly. So depending on what you're wanting to plant, you may have to kill or terminate that crop fairly early in the spring before it gets too tall. Hairy vetch. Hairy vetch is a legume. It's going to supply nitrogen through its fixing properties. Again, it'll overwinter. It'll help outcompete weeds. Now, the one problem with this, and to a certain extent, the rye, there's a little bit of allelopathy that can occur. So one of the things that you may need to consider is, killing these plants out fairly early in the spring and waiting, or, having about maybe a 4-week window at least before you plant into that area, so you greatly decrease the potential for those allelopathic effects to take place. Sweet clover, that's another one that used to be one of the big green manures in the early 20th century. I can remember my dad planting that on our farm. Now, with this, you're saying, well, I've still got stuff in the garden. How can I put these cover crops in? There may be some situations where you may need to do some overseeding if you're wanting to get a certain cover crop into the soil before the rest of the crop is harvested. Again, depending on what it is you're wanting to put in there. Now, here's some examples, and to be honest, I think these poundage recommendations are pretty high. In fact, they may be way high. I think you could cut back on these substantially and still get a good crop in here. In most cases, they're talking about a pound per 1,000 square feet. That's a lot of material. You could probably cut back by a half easily, if not more, and still get a cover out there with it. So with some of these that overwinter and come on in the spring, again, you're going to have to terminate that crop. How are you going to do that? A lot of folks don't want to go the Roundup route. That's one way to do it. If you're not going to go that route, then you're probably looking at mowing or some type of hand termination. So in other words, whether you're using a weed, possibly a weed whip or a weed whacker, if it's not a very big area, for something like maybe rye if it's fairly small, or some other options, maybe a scythe, or again, depends on how big of an area you have with that. The other thing to know is if you try to plant directly into that, so you terminate the crops and the residues are there, and you come in a couple of hours later or the day after and try to plant into that freshly terminated crop, there still may be some allelopathy there. So again, it's better if once you terminate that spring crop, wait about 3 to 4 weeks before you plant into it. If you've got a large amount of material, you may end up having to pile it off to the side. Hopefully you've got a compost that would make great compost material, lots of nitrogen in that fresh green material. Okay, I'm going to go through this. We've got about 6 minutes left, and then I am going to hang on for questions. So one of the things that this particular study did, this is by Jerry Bruce. He's actually a vegetable specialist out at the University of Maryland. But he did a 5-year study where he did cover crops of rye, hairy vetch and rye, tillage radish, and no cover crop, and looked to see how those things worked in a no-till situation. So you're saying, well, if there's no tillage, how do you terminate those crops? Well, on a larger scale, this is something that was used. It's called a crimper, where they fold that behind a small implement and it crimps the plant, it desiccates it, and then you have that residue left behind. So here's an example. If you're reading this, these are all different areas where the cover crops were crimped and rolled about 2 weeks prior to that picture being taken. And you can see the sweet corn is coming up. So in this case, they really didn't wait that 3 or 4 weeks. They planted into this area about 2 days, or just a few days, after the crimping took place. And you can see the sweet corn coming up through that residue. About a month later, this is what it looked like. Now you can see in some areas it's relatively weed-free, but in the background, that was in the area where there was rye. You do have some grassy weeds coming in. So if you're still trying to do no-till, how do you take care of weeds and you're still wanting to do a no-till situation? Leave that residue in place. Well, this shows what, and everybody that's garden knows how quickly it can get out of hand. So what they did in this case, where you see those weeds, is they went in and brought in some barriers. And what they did was they would place these barriers in between the rows. They would let it sit for about 2 weeks. And then they would move on to another section, put that material back down, let it sit for a couple of weeks. And this works especially well, they found out, when it was hot conditions. It helps basically fry those weeds, seedlings. This is 2 months after that weed barrier had been put down, and you can still see how clean in between the rows are. With that residue in place, it essentially creates a stale seed bed. So once you've got that first flush of weeds killed out, new weeds don't seem to come through. Now again, is this going to happen in 100% of the cases? No, but it's showing you have the potential of doing this. You can walk on this mulch, you can do what you need to do to the plants, but the amount of weeds coming through that is almost non-existent. What is the weed barrier made of? That's a good question. I've had that asked multiple times, and I failed to find out what the exact material is, whether it's just the typical weed barrier that you might find at a retail store, or plastic. I'm guessing it may be just a type of black plastic that you could put down. Now this was a little bit different situation. I've only got a couple of slides left here. This is winter squash that was transplanted into an area that had area vetch incorporated. It was mold and mulch. And in both these cases, no weeding was done. So another example of where you can see that residue in place and kind of keep the weeds down to a minimum. All right, folks. I'm gonna stay on here for anybody that has any questions. Here's my contact information. I'll leave this up here for just a second in case anybody afterwards wants to send me an email. You're more than welcome to do that. Again, that's friend@illinois.edu. And the phone number is 217-243-7424. And here's some past, if you want to see past recordings, you can go to go.illinois.edu/4 seasons recordings. And I will start with questions. So one question we have, can you recommend a specific cover crop that is most effective in lowering pH? I don't think any of them are going to help lower pH to a great extent. Most of the cover crops are not going to have a major change, especially in lowering pH. So unfortunately, I'm not aware of one that would help lower it. Another one, does SOM stand for soil organic matter? Yes, it does. Is there allelopathy after radishes? No, because for one thing, those radishes die out in the fall after the first frost, and essentially they're gone by the time you plant in the springtime. So I have not heard of any problems with allelopathy with the tillage radishes. Good questions. Here's another one. If I top dress my garden with leaves, composted manure, or wood chips, will it eventually be worked into the soil by earthworms? No tilling at all. It will, but it's going to, you're not talking about just a few years to do that. You're talking probably decades. If you put even several inches of that material on there, it is going to decompose. Now, if you have a lot of earthworms, especially the night crawlers, they will work on it, but especially the wood chips, that's going to take a very long time to decompose. And so it will take a very long time for that stuff to get worked into the soil. Okay, last few slides were hard to read. How can we get readable slides? Well, the one thing I would say, if all else fails, and I don't know if any of the Hort folks are on there that do this regularly, but I'll tell you, just if nothing else, send me an email, and I will send you, a copy of the PowerPoint. Again, that email address is friend@illinois.edu. Where do you purchase the tillage radishes? I would say go online, and you may be able to find them. I think there are beginning to be a few farm and home stores that may sell them. You may be able to go to your local FS and get them there, but I would just do a search online. I know you can get them online. Same way with the other cover crops. Again, you're not talking about very large amounts for these things. And I wouldn't just go to one on-site location and take the first thing you see. I would shop around because there could be a price differential between them. I would talk to those people, whichever ones you were thinking about. I mean, I would talk to them over the phone, kind of get a feel for if they understand what you're going to be using it for. Get as much information as you can before purchasing online, which is pretty much common sense for any type of online purchasing. Oh, there's something, somebody says territorial seed, 4 ounces for $3.95. Okay. All right, excellent question. So we have other questions. All right, I'm not hearing any. So again, if you do have questions and you don't want to ask them right now, feel free to send me an email. Okay, here's one. Harry Vetch, do you till it in? You can till it in if you wish to. And again, especially if you're going to plant into it, I would till it in. I would wait a couple of weeks at a minimum to plant into that because there still may be a little bit of a allelopathy effect from that in the springtime. Okay, well, I thank everyone for attending. I think at one point I saw up to 75 on the participant list, so great attendance, great questions from everyone. Hopefully I gave you some food for thought on different things. And again, if you have any questions, feel free to contact me at any time. At this point, I am going to sign off. So again, thanks everyone, and hopefully we will be talking to you at some point in the future.